Hi guys, I hope you're good since last video. So in this video we are going to focus on options. We are going to go through the first part, explanation of what are options, why do we need those, and the misuse of options, what are the alternatives. And in the second part we're going to use the terminal to experience it through the code. Please like and subscribe. Thank you for your support, and let's start. Options. Let's define it first. What is an option in Rust? So an option which holds a type is an enum. So we've seen enums that represent either some type, so contain a value of a type T, or none, so represent the absence of a value. The purpose, so used to express that a value may or may not be present. So it's a way to return none in Rust. When to use option. Option values when a function might or might not be able to produce a meaningful value. For example, searching for an item in a collection may not find it, so it may be none. It may return none. Passing data that might be absent or invalid. The benefits encourages explicit handling of the absence of a value. It prevents null-related runtime errors common in other languages. Let's see the example here. So we're going to go through a piece of code just to see how it is formatted. So we're using here the function. Let me find the arrow. Use option at Shibuya, takes a sentence, it's a string, and it returns an option U64. So the type here, the T, is U64. Returns some or none because we're using option. So we go through a for loop just to get the index on the letter. So characters, enumerate. So enumerate is going to help us to pass those two. And after we check with the if statement, if letter equal to y. So we see here, we don't put double quotes, we put single quotes. So single quotes in Rust, it's characters. We find it on return sum. So if we find the character, we return sum. So the index, take the index, and here we're just going to convert it to a U64. Otherwise, we return none. So this is a way to return none. So the purpose here, this function searches for the first occurrence of the character y in the given sentence, returns some index if y is found, so returns the index has a U64, or none if y is not found, so the character y. So let's talk about the misuses of option. So using option instead of result, that's one of those. So the issue here, returning an option when an operation can fail with an error. So at this time it's better to use a result with the type on the error. So result here because it's going to be able to return the error, so to provide error information. Here in this example of this misuse, we can see here, this is a misuse example and this is the correct example. So we talk about the misuse first, read the file, we get the path like we did in the previous video. And here we take a reference of the string, we return an option, should be a string. So here, file reading might fail due to IO error. So you know in the previous video we used IO. So here we're doing it correctly. We read the file, we return a result, it's a string, like here, or we get an error. So that's what we're evaluating here. And after here we use the file system to read what is inside the file. So the second case of misuse, we have 3 cases. So here the second one, overcomplicated with a nesting instead of another nesting. So an option inside an option. So the issue here, nesting option types unnecessarily. So we don't need to do that. We can simplify the logic to use a single option and have more clarity in the code. And the third one, so we don't see here in example because it's just nesting options, don't do it. And using option when a default value makes sense. So when you can have a default value, don't use option, use a default value. That's what it says basically. So here the issue, using option where a default value could be used instead. The recommendation is to provide a sensible default to avoid unnecessary option handling. Example, instead of returning here an option usize, we return the usize directly. So function count items, item, and here we get the reference of that array of items, and here we return a usize item length. Return 0 if the slice is empty. Okay. After that, what to do instead? So let's refocus on that and talk about what to do. So you use the result for error handling. So when an operation can fail and you need to know why, that's why you're using a result. You provide default values when an absence can be represented by a default value, and you avoid unnecessary wrapping. So keep types as simple as possible for clarity and ease of use. So think also at your team of developers or of new developers coming and reading the code. So having those super nested options inside options can be overcomplicate the code reading and review. So do we need to implement display? So I had this question in my mind, do we need to implement display for option? So let's answer to this question. No need to implement display for option manually. So option with the type already implements display if the type implements display. So option itself is not implementing display. So we're more focusing to the type that the option returns. So it has to implement display. So if you have a struct type, you need to implement display because that's custom, because you're creating your own struct. So here in the example, we use option U64. So U64 can be printed using curly braces, so without using any debug mode, so the colon and the question mark, because U64 implements display. In the example, we have the main function, we instantiate a variable result, we use a function inside, use option at Shibuya, string, from, so that's the parameter, and after we print using the curly braces. So we'll print some index or none. Because this function, as we've seen before, when we have defined it, we said that it's going to return an option. Custom formatting. So if you want to customize how the option is displayed, you can use match. So we've seen match, which is very useful. You can use it also for this custom formatting. So this is another example showing you here how you can do options in another way using match and using directly the function sum. So let's go through this example. We do the same here. We instantiate this let result, this variable with the function inside, calling this with a parameter. We match result. So here it's going to return sum. That's the sum option side. So the side of option which is returning sum index. So that's just a placeholder. And after here, println, and we just need to use the normal curly braces, and we put the index. So whatever this returns is going to be printed here. We found Y character at position, and here we got the index, a U64. And here we got the non-option side, none. So it's going to just print this sentence to say that we haven't found the character. We're almost done. We're just gonna repeat again. So you use option appropriately when a value might be present or absent. So not for error handling, where result is more appropriate. So you need to evaluate if you use result or option. Printing option values, so you can print directly if the type implement display, and use the normal curly braces. So as soon as if it is not a custom type, or if it is a type that has display implemented already by default, you can just use the normal curly braces to print. You can use match, as we've seen just before, or if let, that was the other way to do the match, to handle the some side and the none side of the option by explicitly returning those ones. So case explicitly for cleaner messages. Avoid unnecessary option usage. So don't use option when a default value suffices. Don't use option to hide error use result instead. So you use the result instead when there's an error, when you know that an error can be returned. Alright, so we're done with that. Let's jump into the terminal. A little break. Please like and subscribe. Thank you. Now, that's what we've done last time. Let's create a new file. We're going to call it, I'm going to call it just a simple one, options.rs. So let's see a general example first. And after from that, we are going to derive and see different misuses and how to use it correctly. So we are going to use here a series of functions to represent the different examples So the first one here will be the general example. What is an option? And we're just gonna be defining a function. Let's put it public directly. I don't need to explain it anymore. Now you got it. So we're going to define this function. We're going to call it useOption at Shibuya. The parameter is a sentence of type string, and we want to return an option. So we want to return here an option of type U64. So as you've seen in the explanations, the first part that we've seen before, we got we got an option that returns some or none. So that's what we're doing here. We're just gonna overcomplicate it a bit, doing a for loop and check that sentence, add some conditionals. So for index and letter, in the sentence, we're gonna iterate through the characters, and we're gonna use enumerate to just have the index and the letter separated. If the letter it's equal to capital J, we're going to return something. So we're going to return the positive side of the option, the sum. Index has U64. So indexes in the Rust, otherwise we return none, but indexes in Rust are U sizes. So it's another type of integer. I'm going to close this. So that's why we're using index has U64, just to convert it back to U64. So unsigned int 64 bytes. So here we go. We're going to go into our main.rs. That's what we've done last time. So let me comment it out. Forgot to prepare it. And maybe let's empty this. Okay. So just going to use here the print with a colon question mark. We import our module, options. Was it options? Yes. Semicolon. And here we're going to be getting that function, use option at Shibuya. And we're going to be creating a sentence here. We can put here a sentence and use a toString, or we can use it like that, just creating a string, double colon from, and here we put our string with double quotes. And we call it Junko is in Shibuya. Very easy. And we're trying to get that index, capital J, which is here the first character. Let's go. Let's call cargo and run the build. We got some 0. So we get the answer 0. That's what we want. So we found it. That's why we see sum. That's the sum side of the option which has been called. And we got the answer inside 0, which is the index. So let me just here, for the people who don't know about indexing, 0, 1, 2, 3, 4, 5, 6. So whichever character you see under the numbers, that means that's the index of that number. How I'm gonna do for 10, 11, 12. I'll just put a 1 for 10, 1 for 11, and after 2 for 12, 3 for 13, 14, and those are those indexes. So it goes to 19. Let's format this. Let's just say here, it's the tens. Okay. So that's how we can accede to the indexes if you never done that before. And we can maybe after that change the sentence and then maybe move the index and see what we just Control C here maybe. I'm not done yet. Okay, I got it back. Now let's create another sentence. I've copied the name, and what we're going to say, we can see Junko. And you see here the J, it's above the 1 after 10, so it should be 11. See here 1, it's tens, so it should be the 11th that is printed in the sum side of the option. And here we got sum 11, so that's the right index. So this works fine for the positive side of the option. And let's end this example by getting rid of the J, so we won't find it. We put a uncause in Shibuya, so that's a Japanese term. That's your first Japanese term that you're gonna learn, which is a bad word. It's not a bad word, it's just that's how you call this stuff, as you can see here. So we're gonna see if it's gonna be a yes or no. But Shibuya is very clean also. It can be dirty sometimes, but in Japan, you know, everything is clean. That's the normal rule. And we got none. Everything is clean. So we got the none side of the option being printed here, not because Shibuya is clean, but because we didn't find the J. So option instead of error. Let's see our second example. Here we're gonna put a decorator that we've seen before. Hello. Just to prevent the warning coming to say that we are not using it, because I'm going to use each function separately. Hello that code. Having this decorator, this function will be ignored by the compiler if we are not using it. That's our first example of misuse. Misuse of options. I'll just put option, error, case. Let's create a public function to illustrate that. I got rid of the, decorator on the other function, so that you will see the warning in the compiler. Because I just talk, but it's better just to see it on the compiler. You see me fixing it, and after you understand that we need to use it sometimes, just to not have this warning. Have a clean terminal while printing, so that we can debug it in an easier way, instead of having all those warnings. So here we have a public function with file. We're passing a path, which is a reference to a string. Option returns a string. So file reading might fail, but here you see we're using an option, So due to IO errors, let's use a match here. Standard library, we're just gonna import it at the top. File system. So let's use it. Use std fs double colons, and we put the semicolon at the end. So now we can use it here. Is the function read to string. Fs file system read to string. So we're going to read the content of the file. We pass in the path. And after here, we're using match, which has an OK side and an error side. But here we're just returning OK content, and we say that if it is OK, we return some content. And for the errors, with the underscore here as a placeholder, we return none. So that's a misuse of option. So we're still returning some and none as the option requires it. But you see here, just when you see the match, we put the OK on the error. Natively, you can see here that you better use an error, because you're not going to be able to catch it as you return none. So if the file doesn't exist, you won't be able to catch it. Let's modify this. Maybe we're going to get rid of everything. Just going to get rid of everything. What was the function name again? Read file. So we used different files that we're going to reuse here. In the previous video, we had those files with the dev secrets. And the first secret, we're going to use first secret here. So file secret. And we're going to check the content of it, if there's any. I'm not sure. And here the println. Can we call it in the println? Let file contents. So the file content here, I need to put a semicolon. It's going to hold the answer. When we check if let some content is the placeholder, file content. So if it is the sum side of the option, which is printed, returned. At this time, we can println something, maybe println the contents. And here we use content. We don't use semicolon, we don't need it here, because in that scope, that's the only call. Else, what do we do? We're going to print something else. Let's print that. Failed to read file. Let's go to the compiler. I'm just going to check first ls files. So there's no underscore, and we need to add the extension .txt. There's nothing in the first secret one, so we're going to be writing a sentence. This is a secret. Let's put it in. This is done. Let's go back to main.rs to make those changes. So we don't have any underscore here. And it's a .txt file. Let's clear the screen, call cargo, unclose delimiter, mismatch closing delimiter, unexpected closing delimiter. I've done something wrong, which is coding all this code inside the println. This won't work. So here everything is fine. We're doing the else statement, but as you can see, println, we can't be calling that inside the println. So let's clean this up. Failed to read file. Why? Why did you fail? Let's change this one here, little typo. And the file name maybe has a problem. Here is first secret.txt. So here we got the other side printed because the file doesn't exist. So you see we didn't get any error. We got failed to read file. So normally here should be an error because the file doesn't exist. As you can see here, there's a typo. It's called first secret. So we're missing the T here. Now first secret, you have the T. And here I'm going to put the decorator. As you've seen before, we got the warning. We run it, and now we get it. This is a secret. That's what we have written in the file. This is the sum side. And in the main.rs, we got the example as at the beginning. Here I'm just going to get rid of the secret, so the name doesn't exist. So you get the none side, which is a printing failed to read file. So now let's see how we should be using it instead of doing it this way. So we should be using error handling properly with the error from standard library IO. We used it in the previous video. So standard library IO. Let's modify this function now. We still got the pass, but we don't want to return an option anymore. we want to return the result. We still need the string or IO error. Okay. And here we don't need to use the match even. We're just going to call the pass using the read to string. If it works, we're going to get the content. If it doesn't work, it's going to be returning an error. Let's delete everything and now use the match here. Maybe we need to instantiate variable before. So that's our function. We're going to pass in a path, files, first secret.txt without any typo this time. Which is going to return OK. Just going to do it like that. We do the match here. No need to instantiate any variable. The content is a placeholder, which is going to just get the content of the file. And we're going to print it. In the case of an error, use the placeholder E here. We use the E println to get the error. And if there's any other unexpected error, because we're using E println, it's going to panic, and we still will be able to catch that initial error that has caused that. Let's call cargo. This is a secret, everything is fine. And now we create the error by altering the name of the file, get rid of the T. Error reading the file, no such file or directory. So that's the right way to use it. You want to return an error when there's an error, not none. Misuse, example 2, nested options. Hello, that code. I'm going to use here the decorator in this function to ignore it. We won't use it. Don't worry, compiler. And let's go into our second misuse example. Misuse nested option inside. We have another option calling a type. Okay. Doesn't mean it's not going to work. Just means that you can maybe make it a bit more simpler to read. Always having in mind of this new colleague coming or another developer looking at the code. It has to be easy to read. Don't overcomplicate. So here the public function get value returns an option of an option U64. How are we going to do this? I'm just going to return sum of sum. I'm just going to nest everything. We put 114 inside, so it's a U64. So we compile here. And that's it. Let's go in the main.rs, and we're going to be modifying this. For this example, we're going to use if let instead of match. It's another way of matching. We've seen that before. So it's a nested sum. It's a nested option inside another option. So here we use sum. We call the integer 104. Just let me call it like that. And we're going to evaluate if get value. It's a sum of a use64. It's an option of use64. So here we just print the value. If it is positive, 104. Cargo run. So here you need to add options because it's coming from that module. You see, it doesn't print anything. Because it's not, it's 104. In the other side, we said 115. So let's put the else statement just to have something printed at least. You are doing it wrong, mate. Oh, we're doing it wrong. Okay. So we didn't find the right value. Let's put the right value now. 114 it was. We found 104. So you just change your print accordingly. So the print statement, I haven't changed it, but you understand how it works, which is fine. And here, let's just modify this. So we don't need to use a nested option inside another option. We can simplify it, even if it works. So option use64. That's what the function is going to return instead of an option of an option. Should I change also? Let's here also just return a sum. Put 115 because we were just thinking about this number before. 115. We got a get function, get value, returning an option of use64. Let's go back in the main and change those values. So we're just returning a sum this time. There's no nesting. 113, for example. 115, it should be here. We call cargo. Okay. Errors. What did I do wrong again? Yes. Can you spot it? So expected one-off. After it just says is expecting, but there's a typo actually in the option. Nano. We go back to the option. And we're going to get rid of that little character. Here, I don't know how to call it, but this one here, we get it. Okay, you are doing it wrong, mate. So we didn't find the right number. Here, 115. Let's run it again. Value found 115. So you don't need to overcomplicate. stuff, just use a single option. Now, let's see another example of misuse. Let's put the date code on the top of the function. And now we are going to do our third case, which is a misuse option used when default value is better. So we're going to define here another function to illustrate that. It's always good to see those functions, which are good and bad, but we're going always into the main.tf to print it, because you need to see different ways to handle it while you're manipulating your code. So public function count items, takes an item, an array, few 64 values, and having here the reference of it. It's better to play with the references when it's like that. We're going to return a usize, an option usize. Okay. So I'm going to comment on usize also after. It's another type of integer. We've seen the unsigned integers, so positive and negative, or only positive integers. And the usize is a reference. So for indexes, for example, you can use it, as Rust is using usize for indexes. So if items is empty, we return none. Otherwise, we return the length of the array. Let's just comment on the usize. Here usize is also a type of integer, but will detect the underlying system. Yes, I forgot also to say that. If 32 bytes is going to be a 32-byte positive number, otherwise it's going to be a U64. So if it is a 32-byte system, it will be detecting it and using the I32 and I64 for the other one, but it's not I, is U. So it's unsigned. It's positive integers only. Can't be negative for usize. It's, the logic way to see it is just it is U size. So unsigned. That's how I see it. I don't know if it is correct. So U32 or U64. So depending on your underlying system. So indexes are also in Rust expected to be usizes. So you can also convert those usizes into unsigned integers by using we did that before, the as keyword. So put index as U64, for example, index as U32. We will see it. I'm gonna use it anyway, because we will need to convert the U64 characters which are in the array. The function is ready. We got the explanations. Let's go back to the main function, do the same gymnastic here. We're going to modify this. Should I just get rid of everything? Yes, it's quicker. Let's start fresh. So we're not using iflet, just use a match. Let's instantiate a variable before and create a vector. Let items vector with some random numbers, 109, 7,000, 75,012, and 2007. Just random. And after that, we're gonna match on the function that we've created. Options, double colons, count items. We take the reference of the vector. We pass in the reference so we can play with it now without any ownership issues. Sum count, we put a placeholder count, so we return sum count because count items is returning an option, so here we have to return sum or none. In this case, we're going to be printing item count, and in the case of none, we're going to be printing another sentence. Let's put no items. Very simple. Okay, we got a vector. We take the reference, and here we have the two different option ways, sum or none. So here there are some values here. So yes, item count 3. We have 3 different numbers in this vector. Let me create maybe a double of this. I'm going to comment this out because I'll be using it after. And here we're going to use let items equal vector empty. An empty vector. Let's call it again and see what is going to be printed. No items. So that's an option. But here we're saying that it's a misuse. So instead of returning an option, let's modify this function. We don't need to go and return options. So we're going to change this function here. Let's empty everything. Here we don't return an option usize. We just return a usize directly. So we can see it has the default that we can return. And after, items length directly. What is interesting here is that it returns, just going to put it like that so you can see, it returns 0 if the slice is empty. So here we get our default value. And it's very explicative. It says no, it says 0. So we're dealing with numbers. We got how many numbers is in the vector. Let's go that. Let's print that now. So here we have 3. It's going to be printed. It's the sum side of the match. Same, here we get rid of everything. We don't need the option anymore. What are we going to do? We're going to be calling our function. Let count equal options, count items. We're going to put in as a parameter the reference of the items. And we're just going to print it. Let's print the result. Item count, a number, and the variable that we just have created. Let's go and call cargo run. Let's make this build. item count 3. We got it right. And let's do the same here. And here we get our default value, item count 0, instead of using options. Let's clear this. Let's see an advanced example, option with a struct type. So now we're done with the misuses and the correct way of doing it. We're going to be creating something more interesting. Let's play with it a little bit more. This is the last example, but it's the most interesting one. Here, I'm just going to put a little comment. Force more complex here, custom. So we're trying to use what we've learned before, trying to implement it here and make it a bit spicy. So to wrap it off, I'm going to start by creating a public struct. So I use a rectangle as the example we used before. Well, let's make it simple. I'm just going to use this one, rectangle. I'm not going to be creating a Shibuya stuff. So rectangle width U64 and 8 U64. So here the overcomplication is on the option side, not in the struct. So we're going to be focusing more into the subject of the video, options. So we are not going to implement formatting also. Let's keep it simple. As you know, when you create a custom struct, you implement display for user-facing display. So data returned. Therefore here we will just use the debug decorator. So now you know that debug decorator exists. You're not scared of it anymore. It's a dash put between braces, deriv, and here the function deriv is going to call debug. Let's close those comments. We got a struct, it's public. Let's go for the function now, the public function that we're going to use in main.rs. Validate rectangle. Rect. That will be the parameter, which is of type struct, which is the rectangle that we have created before. The option is going to be also of type rectangle, so the struct type. And here we're going to be implementing a logic. Let's use here a range of variables for the width and the height. So if from 4 to 10 included contents, we're going to use here a reference of the rectangle. So the rectangle rect width. So we want to check if it is between 4 and 10. And at the same time, the height is between 20 and 30. So I'll put it in this line just to write everything in one block here, but I'm going to put it back normally. So here we have the ampersand rect. We take this reference, same. We're going to be getting that 8 field. We got the 8 field. So if we got those two conditions, we can return the sum side of the option, the positive side of the option, which is just returning the rect, which is the right type, because the option is returning a rectangle, else we return none. Let's put it back here. So we're good with this function, don't need to re-explain it. So nano main.rs, let's go in and let's create our logic. Should we clean everything up? Yes. So what are we going to use here? Let rect. Here I'm going to instantiate this rectangle in a variable rect with the width of 3 and the 8 of 25. Put the semicolon, that's the variable that we have created. So we put the semicolon, let validated. Here we call our function, which is going to be checking if it is a sum or if it is a none, or we put the rect inside of it. We could have also used here the reference of rect in the validate rectangle as a parameter to enter it, but we're going to use it just like that. And as you've seen in the function before, I've used the references. I'm playing with the references anyway inside the function. We print ln in debug mode, so colon question mark. So colon question mark is okay, but the rectangle cannot be formatted like that. So it's suggesting us here how to import the crate, or the struct that we've created. Because have you seen I put it public, but I didn't put the field as public, so not found in the scope. So compiler errors are part of the learning. That's what we've seen before in the structs. Here, this one. So we need to put the decorator deriv debug, as I don't want to implement display for it. I put deriv debug, as you can see, but it's a capital letter for debug, so this is not going to work. Let's see what's going to happen now. Let's just go through it step by step. We have less errors. Rectangle not found in the scope. Okay. We're gonna import it. Is it like that you import a struct? Mod? No. So let's go back in. Let's see the error. So expected semicolon. So here the error is just telling us, just to show you that the compiler is explaining you about how to use it, but it's not right here. It's just because we use mod. It's not mod. You don't use mod to import a struct. Just going to get rid of it first. Recall cargo. And here you see, now the compiler is giving us the right command, which is a use crate option rectangle. We're going to use what we've used before. Use options rectangle. So from the module, we want just to destruct. We're going to run it. It's not going to work. Now we are at this step where we can see that the fields are private. As we've seen in the previous videos, we used public for all the fields. So let's use it that way here also. So we're not strictly following what the compiler is telling us, because we want to use it in a certain way. And this way works. And now we got none. Why it's none? The none side is printed because we're not in the boundaries. So width is 3 and 25. So here I'm just gonna check what was the boundaries. It was between 4 and 10 for the width, and 20 and 30. So for the 8 is fine because the 8 is 25. But the width, we're gonna put it in the right range to get the sum side of the option printed. So to validate our rectangle. So you can use it that way as a validation. Sum rectangle, and here we got it right. We got the rectangle back. So this is another way that you can use it. So use options to validate your struct, for example. So put it in your code. If it is validated, you can keep going. In your logic. So we've seen here the different ways that people are using options like that, but it's a misuse of option. 3 different ways, here with the count also. And after that, we've seen also the use size. That's a new for us. And we've been through this complex example using a struct. And that's an interesting way of using options. All right. So we can stop here. In the next video, we might see where are we gonna go. Heap stack maybe, or focusing on the strings, just to go a little bit more further into the topic. Hope that you like this video. Please like and subscribe, and see you next time.